Hello and welcome back to my channel. So today we are going to solve a few questions based on my previous video. I'll keep the link in the description. So we were discussing about limits of trigonometric functions. We discussed about the inequality involving cos x is less than sine x by x is less than 1 for all values of x belonging to in 0 to pi by 2. So we discussed about that, and so today we are going to solve some problems based on this. So let's begin. So problem number 1 is we have to find the limit x approaches 0 sine x by x. Now we know that from the previous video that cos x is less than sine x by x is less than 1. That means the value of sine x by x is in between 1 and cos x for all values of x belonging to 0 and pi by 2, in between 0 and pi by 2. Okay, wait a second. So let's make a graph of this function. We don't really have to solve this, and when I make a graph of this function, we can solve this problem within like 2 seconds. So let's make a graph of this function here. I'll make a small graph. Like this is the vertical axis, and this is the horizontal axis, right? And on the vertical axis we'll keep 0 and 1, right? We'll first make the function, this function, right, 1. So this has only one value, that is 1 for all values of x, whether it be 0, whether it be pi by 2 or pi. So it'll always be 1. So that means a straight line, right, joining 1. So let 1 be at this point. Similarly for cos x revolves around 0 to pi by 2. We have cos 0 is 1, and then for pi by 2, cos pi by 2 is 0. So it will be the function will look something like this. Okay, so here it's minus pi by 2, it's pi by 2. So let me just write it neatly here. We have pi by 2, right? So when cos x is 0, we have cos pi by 2, the value will be 0, and like this it will go like this, and again we have pi here, pi by 2, pi. So cos pi will be again minus 1, like here. Same. So this is the graph of the function 1 and cos x, right? So at this point when x is approaching 0, right, it's 0, we can see that cos 0 is 1, as well as the function 1 is always 1, so it will be here. And also due to this equality that we discussed in the previous video, we can see that the function sine x by x is actually in between cos x and 1. So that means automatically when x approaches 0, so the value of sine x by x will also be equal to 1, right? From the theorem that we proved, sandwich theorem, in the previous videos. Please have a look at that also. Also, if we want to solve it, we can write like this: limit x approaches 0, cos x equals 1. We know that, right? Because cos 0 is 1, and then function 1 will be 1 at any point, and then therefore when sin x is, so cos x less than sin x by x is less than 1, that means automatically limit x approaches 0, sin x by x equals 1. And this is an identity true for all, this one is true for all values of x in between 0 and pi by 2. So you always remember, if you get something like this in limits, you can just write it's equal to 1 when x is approaching 0. So moving on to another problem, another question, we have find limit x approaches 0, 1 minus cos x by x. So from trigonometric identities, I'll also make a new video on trigonometry. I'll make a new playlist so we can have a look at that. So from that we can learn, there are many trigonometric identities given in that, so I have taken one which is suitable for this question. So I have used one trigonometric identity as given as 1 minus cos x equals 2 sine square x by 2. So we can just simply substitute this one into this function, and we can write limit x approaches 0, 2 sine square x by 2 by x, right? So this 2 will come down, it will be x by 2. In the denominator we have sine square x by 2 by x by 2, right? And the limit as x approaches 0. So here from the previous question and the equality that we did, we know that limit x approaches 0, sine x by x is 1. So we can simply apply that. We know that even if x by 2, if x is approaching 0 here, this will be 0 and this will be 0 as well. So that means sine x pi by 2 by pi by x by 2, it will be 1. But here we have sine x square, so we'll simply just kind of expand it and we'll get limit x approaches 0, sine x by x by 2 by x by 2 multiplied by sine x by 2, right? So this whole thing will be 1, this one will be equal to 1, right, from the previous equality that we have. So we can simply write it as limit x approaches 0, 1 times sine x by 2. So limit, if I apply as x approaches 0, x by 2, this will become 0, this one will be 0, so we are left with 1 times 0 equals 0. So the answer to this question is 0, not 1. So thank you for watching, and I will link the previous video in the description, and also make new videos, new playlist on trigonometry, so that you'll be able to understand all the concepts in your syllabus and learn maths easily. Thank you for watching.